Hi, kings and queens, and welcome back to another exciting episode of Mr. Alcaro Teaches You Something. Now, you guys have been working with operations since the early grades. More recently, you guys have learned about exponents. You remember what exponents are, right? Well, allow me to refresh your memory. You see that little 4 floating above the 5 with the arrow pointing to it? That's an exponent, and the 5 is the base number. This can be read as 5 to the 4th power. The exponent tells us how many times to multiply the base number by itself. So 5 to the 4th power is the same as 5 times 5 times 5 times 5, which equals 625. Here's a mistake that I see a lot of scholars make. They know when they see an exponent that multiplication is involved, so they simply multiply the base number by the exponent. But clearly we can see that raising 5 to the 4th power, which is 625, gives us a very different answer than when we multiply 5 times 4, which is 20. I hope you enjoyed that little refresher on exponents. But by the end of today's lesson, you will be able to write and evaluate numeric expressions using the order of operations. You see, when multiple operations are present in a single expression, the meaning of the expression is defined by the rules for the order of operations. When there's, say for example, addition and division in one expression, in order for you to be able to correctly interpret that expression, you have to use the rules for the order of operations. Scholars, you'll need to understand these rules and apply them accurately in order to be able to rewrite, simplify, and evaluate expressions. Right now, we're just going to be working with numeric expressions. But why this is important is because as you gain proficiency, you'll be able to apply the same principles to expressions with variables. Well, why is that important? Because as you begin to work with variables, you start doing what is called algebraic thinking. And that's going to be important as you continue your educational journey. And algebraic thinking is an important part of problem solving. In today's activity, you guys are going to be trying to reach a target number by performing operations on a set of numbers. You'll need to communicate the order in which the operations are performed by using the order of operations rules. Check this out. 3 plus 4 times 6. This is an expression that contains more than one operation. There's addition and multiplication. Notice that depending on which operation we performed first, we got different results. So, do you think there maybe should be some set of rules that we could apply that tell us which operations we should perform first? Why do you think we need a set of rules? Right. We need a set of rules to ensure that everyone gets the same answer every time. Well, lucky for us, just such a set of rules does exist. It's called the order of operations. And hope you don't mind, but I brought a friend along with me to help explain these rules. Before I introduce you to her, though, I should probably let you know that she's kind of hard of hearing, and as a result, she talks a little loud.
Hello, kings and queens! I'm Mr. Alcaro's
Embarrassing is an understatement. Ladies and gentlemen, with that said, you'll have to please excuse my dear Aunt Sally.
Please excuse my dear Aunt Sally is actually a mnemonic device to help you remember the rules for the order of operations. Because the first letter in each word of that silly sentence corresponds to one of the rules for the order of operations.
Okay, thanks, Auntie. I think I should probably take over from here before all of our eardrums explode.
I'm sorry, I didn't quite catch that. Were you asking me to teach the whole rest of the lesson?
No, that's not what I said, Auntie. Just leave. She was right, though. We can use the saying, "Please excuse my dear Aunt Sally," to recall the rules for the order of operations. Let's take a look at how we would do that. First, perform operations inside of parentheses. Then, evaluate any exponents. Next, perform multiplication and division from left to right. Last, perform addition and subtraction from left to right. For today's activity, you will need a number cube, or what we usually refer to as dice. For those of you who don't have dice lying around, I have taken the liberty of attaching a link to virtual dice. Now the first thing I'm going to do is roll the dice 5 times to generate 5 numbers. Next, I'm going to roll the dice 2 more times and multiply those 2 numbers together to get my target number. Here are our numbers and our target number. Now that we've created our puzzle, it's time to solve the puzzle. What we're going to do is write an expression that contains the 5 numbers in any order with any operations, including exponents. Each of the 5 numbers must be used exactly once. The goal is to write and simplify an expression with a result that is as close as possible to our target number. Remember to pay attention to the order of operations rules. As we grapple with this, I want you guys to think about, is your expression less than or greater than your target number? Can you see a way to write an expression that has a greater or a lesser value? Can you work backwards from the target number? Have you tried using exponents? Could you use a different number as the exponent? Would someone else evaluate your expression the same way you did? Do you need parentheses? Have you thought about how using parentheses kind of lets you override the order of operations? Which one of my brilliant scholars came up with an expression that exactly equaled our target number? Here's an example of one, but don't take my word for it. check for yourself. Now it's your turn to create and solve your own puzzle. You'll submit your work, and I'm going to see if I can come closer to the target number than you did.